Hydropneumothorax. In this session, we are going to learn how we can identify hydropneumothorax in chest X-ray. The key finding in a hydropneumothorax is a straight line. This straight line indicates air-fluid interface. It occurs only in erect films, and in supine films it's kind of difficult to identify. Let's learn about the air-fluid interface. Imagine you have a transparent cup in front of you and you pour water into it, filling it till the half. Now look at the glass from the side. Look at the transparent cup from the side, and now you have above air and below you have the fluid. Now the junction between the air and the fluid is a straight line when you view from the side, right? Because the atmospheric pressure makes sure that it is in a straight line across. Maybe there might be a small meniscus, but as you visually look at it, it looks like a straight line. So that is the air-fluid interface. Whenever both the air and the fluid is found inside the pleural space, the interface between them is a straight line when viewed in an X-ray. This is a very key point. Because of the air has less density, it goes up and the fluid goes down in an erect film, and the interface between them is a perfect straight line. In chest X-ray, the air looks dark black and the fluid looks white. So in a typical picture, we have a black area in the top, then you have a straight line, and then you have a white fluid below. We'll see in the X-rays. So this is a typical example of hydropneumothorax. I want you to focus on this line up here. This is a straight line. It's a straight line. In nature, it's very rare to find straight lines. In human body, it's very rare to find perfect straight lines. Usually nature, it is curvy, irregular kind of shape. Mountains, stones, whatever you see in nature, it's not a perfect straight line, but here it's a perfect straight line. And as I said, this is an air. This is in pleural space. This is an air. This lung is collapsed, and this is the lung margin probably. And then this is the straight line, and below you have fluid. This is fluid. Compare the right lung. So this is all fluid. This is the air, and the interface between them is a straight line. This occurs only in erect film. Now the key point for hydropneumothorax is it should be through and through. It should start in the medial aspect and end in the lateral aspect if it is a hydropneumothorax, because later on we'll be seeing some X-rays where you will have the straight line confined to a small space, just from here to here, very small space, very small length. Then it means that the air fluid level is inside a cavity, right? So for hydropneumothorax, which means there is air and fluid in the pleural space, usually it starts from the medial aspect to the lateral aspect. And second thing is, for hydropneumothorax, this entire thing should be white because fluid is filling up the space. It shouldn't, if it is white partially and here you are seeing lung, then it can't be a hydropneumothorax. We'll see an example for that as well. So as of now, I think you should have a very thorough understanding of this X-ray. I repeat that there should be a straight line. Never miss this straight line in this X-ray. It should be through and through, and above it should be dark black and below it should be fluid, and the fluid should continue throughout the lung. So this is a next example. You can see a straight line here, right? Above it's dark. This lung is partially collapsed. The pleura is somewhere here. The pleural line is somewhere here. So This is the pleural space, and below we have fluid, right? So perfect straight line. So once you see more and more x-rays, you tend to identify these perfect straight lines. It's very interesting because hydropneumothorax as such is very interesting to find. And while examination, you used to get something called straight line dullness in hydropneumothorax, and this is because of this sort of air fluid interface. So another x-ray. So on the right side you have hydropneumothorax. So above you have the dark through and through from the medial to lateral aspect sort of line, and below we have this white shadow, and this is the pleural space. This is the collapsed lung. This is the straight line. So as I discussed previously, we also have a straight line dullness, and then there is a shifting dullness in the examination. This shifting dullness in hydropneumothorax, that's also because it's because of air fluid space. When you shift the patient to a different position, because of this presence of air and this fluid and air being less dense, uh, immediately there will be a change in this dullness, because if you keep the patient erect and then you shift into, say, left lateral position, so this air immediately comes and lines up in this lateral aspect, and the fluid will come down, right? Imagine a bottle filled with fluid, half filled with fluid. As soon as you topple the bottle and make it lie down, the air, because the air will rapidly move to the top, and fluid tends to go down fast. So similarly, this is a container sort of thing, this pleural space, and you have above air and below there is fluid, and as you change the position, because the air is less dense, it immediately comes on the top and the fluid goes down, and this is responsible for the shifting dullness. I'm showing you more and more x-rays to make sure that you get a good visual memory and then you never forget things. And here it's a straight line. Here this is the collapsed lung, here above is the pleural space, and below it's full of fluid. So another x-ray. So here you see this x-ray, straight line. So here below it's fluid, above it's air. Straight line here, up here. So below it's fluid. This is the lung, it's partially collapsed. This is a straight line. So as you see more and more x-rays, you tend to get that visual memory, and after some time, as soon as you see the x-ray, you identify these things. That is the reason why I'm putting up several x-rays, so that you get, you see, as soon as you see, you know that this is hydropneumothorax. This is something that should not be missed. Now comes the interesting thing. I said that last time that line should be starting through and through from lateral to medial. A complete lung should be involved for hydropneumothorax because the entire pleura is involved. Now you are finding a line here, right? But it is not through and through. But if you see carefully, see that there is a sort of a margin that you can see here, right? Here also there is something round. So this is actually a cavity. It's a cavity. So in the cavity, inside the cavity, if you have fluid, sometimes you have fluid inside the cavity due to infections or malignancy, and then you have this straight line, because when you stand erect and take an x-ray and if there is a cavity with fluid inside it, then it looks like this line. So this is a round cavity and then fluid is here, so it looks like straight line. In this cavity there's no fluid. It is I think you can very well see this cavity. It's a thin walled cavity here. This is also a thin walled cavity, but that is a fluid inside, so it is a straight line. So if you see a small straight line, then there is a possibility that it can be a cavity. This identifying straight line is very, very important. Now you see this X-ray looks almost okay. If you're an amateur X-ray reader, then you will find that yeah, it's almost okay. Then you find that here is a small line up here, straight line, right? This is a small straight line, and above the straight line you have this semilunar shaped round sort of thing, right? This was lung abscess, right? So in lung abscess also you have a cavity with a sort of air fluid interface. So this is a up here. This is a lung cavity. So any if something is very straight, as I said previously, in nature it's very uncommon to have straight lines, especially in human body. Perfect straight lines is quite uncommon in X-rays. So when you see a straight line, it's something abnormal. So here is this lung abscess. So in this X-ray, you have sort of this hyperlucent area, hyperlucent and avascular area. So there is no bronchovascular markings, right? It looks like pneumothorax, but then there is a straight line up here. There's a straight line here. And there are small straight lines here. If you see carefully, there is some straight line here, right? In this area, you can see a straight line. Then something, this also looks straight, and here also this looks straight. So it's multiple air fluid levels in the thorax, and this is because of a diaphragmatic hernia. So the gut has crossed the diaphragm and into the thoracic space. So this is all bowel. So when you see a multiple air fluid levels in the thorax, then you have to be very careful. Diaphragmatic hernias, there are two different types. So one is the Boktelek hernia, and then another is the Morgagni hernia. So here the key important thing is when you see multiple air fluid levels, we have to be a little bit careful. We have to take a CT chest to confirm what the finding is, because the treatment for the hydropneumothorax is like ICD insertion. But if you find some cases like this, then you have to be careful, because if you put an ICD into a bowel, then it can be catastrophic. So it is important that when you have doubt, don't rely on X-rays. If you take an X-ray, you find that something is not quite okay, then always go for a CT scan before you do any procedures. So in this case, it's a diaphragmatic hernia. Another thing is, if there is a hiatus hernia, then around this area you will see an air fluid level. This area, it's not here, but if there is a hiatus hernia, you might see an air fluid level up here. So that's important. So in this X-ray, you're seeing a straight line. It's almost from the medial to lateral, through and through. It's there. So above you have this dark area, right, and below it is a white area. But then you can call it hydropneumothorax. But now you have this lung here. So now it is not a hydropneumothorax, because if it had been a hydropneumothorax, the entire thing should have been filled with fluid, right? So in hydropneumothorax, above it is air and below it is fully fluid. But now you see the lung margin beautifully up here. So it is not hydropneumothorax. So it is again a cavity. It is a large cavity with a air fluid level and with a surrounding consolidation. So this is all consolidation. So this is surrounding a cavity. So it is not because had it been fluid, this CP angle should be blunted, this should be blunted, and it should all these things should be obliterated, and it should be full white, right? So it is not there. You're seeing the lung here, so it is a cavity with the surrounding consolidation. So this is also an interesting X-ray. This is a rare X-ray, so you don't encounter anything. So you are seeing a straight line up here, right? So look at the lung volume. This is larger lung volume, so this margin is up till here, right? And this trachea is slightly shifted to the opposite side, and this is the left main bronchus stump. It is ending abruptly, right? So this is the diaphragm, and this gut and this fundal shadows are here. So this is the diaphragm origin. So here you have above air is that this is a fluid. I'll tell you the case. This is a post-pneumonectomy case. So what has happened is in post-pneumonectomy space, usually after surgery, a serous fluid fills the space till it reaches, gradually it reaches. So the entire empty space after removing the lung will be filled with fluid. Any new onset air fluid interface in a post-pneumonectomy X-ray indicates that air is leaking from the stump. This is the stump, that the left main bronchus stump that the surgeons would have sutured. But somehow, if when there is air is leaking from the stump, then there is a possibility that there will be an air fluid level. Because the air is leaking and already there is some fluid, so there is a air fluid level. It's one of the dangerous complications of post-pneumonectomy. Sometimes the stump has to be closed using bronchoscopic techniques so that there is no further air leak from this thing. Otherwise, what happens is that air will leak from here, and this fluid can go through this, and it will cause severe bouts of cough and infection. And in post-pneumonectomy patient, infection is a dangerous thing. So most people, everyone has two lungs, but in post-pneumonectomy, you have only one lung. So any infection on that lung will cause severe dyspnea, severe infection, very critical condition. So you have to avoid any sort of infection in post-pneumonectomy patients. And new onset air fluid level in post-pneumonectomy patients, always think of like any sort of stump dehiscence and air leak from it. So that's it. Now the main thing is, as my student, never miss the straight line in X-ray. So I have given you multiple X-rays. I have shown you the straight line. I have given you differential diagnosis. What could be a straight line, but it is a different diagnosis. We saw all those things. So whenever you see an X-ray where you see a straight line, the first differential diagnosis that you have to think about is the hydropneumothorax. The straight line should be through and through from the lateral to medial aspect, and above should be air, and below it should be fluid filling. And if that is there, then it is a hydropneumothorax. So we'll have this cumulative learnings slide. So the first session was about pleural effusion. I told you in every X-ray look for the costophrenic angle. The second X-ray, I told you compare both the lung volumes in every X-ray. And in the third session, I'm telling you never miss a straight line in a chest X-ray. Thank you.